Okay, let us start from the part where we had ended in the last video. The epoxide can be prepared with alkene reacting with peroxy acids. Okay, so what is peroxy acid? When you have an acid and you have one more oxygen than the actual number, the supposing acid has COOH, so that is what is acid. So here COO means CO doubly bonded and OH is a normal acid. Now when you have a OO bond, you call it as peroxy bond. Okay, so here it is metachloro peroxy acid, benzoic acid. It is meta 3 position benzoic acid because it is a benzoic acid with an excess of oxygen, so it is a benzoic acid, and this reacts with this double bond in presence of dichloromethane to give you a trans, means these two groups are on the opposite side. We had started with a trans alkene and we have ended up with a trans 3-ethyl 2-methyl oxacyclopropanone. That is what is the nomenclature goes for epoxides. Okay, so let us see the mechanism. It's a very simple mechanism. See, the excess oxygen, this oxygen comes and attacks on this alkene, and the other one also attacks on the same carbon. So this same oxygen, this bond is therefore breaks, and accordingly the pi bond takes this H. So what you get is this H is being taken by the oxygen and the pi bond has broken, and this is the sigma bond which has broken and it is going as a pi bond. So therefore what we get is an acid, and this is the epoxide form. Okay, and sharpless epoxidation, it is actually out of your syllabus, but still I would like to inform you. In case of sharpless epoxidation, it is on sharpless epoxidations are only possible where we have an allylic alcohol. What is an allylic alcohol? This is an alkene and then the next carbon, and this position is called allylic position or allylic carbon. So allylic carbon having an alcoholic group is allylic alcohol. So when it reacts with that means diethyl terephthalate, okay, diethyl in presence of a catalyst, in presence of a peroxy acid, we get, in case of minus det. What is minus? Minus is both the OH groups are on the opposite, are on the back side, or you can say it is SS. When both the OH are on the front side, RR, it is called plus, it is called minus. So therefore it is also called LT. L means levo and D is dextro, so it is LT, L plus det and D minus det. So when you have a D minus det, you get a major product where the epoxide ring, it's towards you, it's in front of you, okay, is on your face, or you can say, and RE means rare face, means in the back side, and it is the minor product. Okay, so therefore it needs a very elaborate discussion, and at this first year stage it is not actually required for you. Let us see the next part, that is reaction of epoxides with acid. So this lone pair takes this H plus, which is coming from the acid, and then the nucleophile can attack the carbon. Now which carbon it will attack, it depends on the epoxide which you are taking. So therefore what you get is a kind of alcohol. Let us take an example specifically. So this is the acid and this is the alcohol. Okay, so therefore first of all this epoxide oxygen lone pair is attacking the H plus. Okay, you have got a protonation step, so this can break. Now which side it will break? It will break in that side where there is more substitution. We have taken an unsymmetrical epoxide. This is a different location, this is a different environment is there. This is having a different environment, environment, this is having a different environment. Now if this bond breaks, you get a tertiary carbocation, whereas if this bond is breaking, you get a primary carbocation. So tertiary carbocation is more stable, so therefore it will be breaking this side, and this is the alcohol which is coming and attacking here. Then again the proton abstraction, and you get a ether. Okay, so this is the product A. Now if the same reaction is done but not in presence of acid, so then what we get something, a different product. Okay, let's see this also, even though it is not there in the course. Okay, the basic ring opening. So in this condition you have a base here. This base will be attacking that particular carbon which is less crowded. Now if you see here, there is no acid, so there are two positions and these positions are different. This is less crowded, this is more crowded, so the methoxy group, methoxide group rather comes and attacks the less hindered or less crowded carbon. Okay, less hindered means it has less opposition or less crowded. Okay, so therefore this is coming and attacking, therefore immediately this will break. This OH minus is there, for O minus is forming. This O minus will be then taking this H from the methanol or the alcohol, and it gives you a different product. So what is this ether is different, whereas the other ether is different. So we are stopping here, we're done with this. If you have any doubt, please ask, or you can give me a call or a photograph in my number. Okay, thank you so much.